Chapter 4, Day 3, Graphing from Vertex Form. We're going to be graphing these quadratic functions from vertex form, and as you look at the list of questions, these may sound kind of familiar. What do A and H and K do? That's because these are going to be very similar to absolute value functions. And just like when we graphed absolute value functions, it's going to be important that you label what I ask you to label. So before we start graphing them, let's talk about that format. And the formula or format of the equation is, again, very familiar. Y equals A times X minus H squared this time. That's what's different, plus K. So it almost looks like an absolute value function. Instead of absolute value bars, it has parentheses. But this is going to be what a parabola in vertex form looks like. And I don't think I mentioned it in these words last time, but it's when it's been translated. So it's the equation for a parabola in vertex form when it's been translated. Now, you might remember from geometry, translations are a type of transformation. There are rotations, reflections, and translations are the three transformations we did that maintained size and shape. They just moved somewhere in the coordinate plane. And so the translation moves the vertex from 0, 0 to some new location with a horizontal shift and a vertical shift, right? So the vertex moves, H is the horizontal shift, and the K is the vertical shift. A is going to determine whether it opens up or down. It opens up when A is positive. Opens down when A is negative. A does something else. It's going to be kind of, I call an A of 1, when A equals 1, it's a normal width. That's not a mathy term. That's just the way I talk about it, because, you know, probably 75% of what we see is going to be an A of 1 or an A of negative 1. So we kind of get used to what those look like. But when A is, and I'm going to put absolute value here because it doesn't matter whether it's positive or negative. Right, so think about, that's going to mean, it doesn't matter whether it's positive or negative, think of the positive value. When it's greater than 1, meaning it's going to be 2 or 3 or 5 or negative 2 or negative 3 or negative 5, it's going to, and again, the non-mathy thing to say is it's going to be narrow. It's going to be a stretch. We talked about it like that when we talked about the absolute value. And when A is less than 1, again, that doesn't mean just all the negative numbers. That means fractions and decimals between 0 and negative 1. Or sorry, between 0 and 1. That means it's going to be wide. Because remember, the A works like a slope. That means it's going to be flatter than it is tall. We call that a shrink. Right, because we really think about it in terms of its height. So its height makes it stretch up, or if it's a small number, it makes it shrink down. Let's do y equals x minus 6 squared plus 2. So I always want you, just like we did with absolute value, write what does A equal, what does H equal, what does K equal, and then just like before, HK is going to give us the vertex. So in this case, remember, A is invisible here, but it's going to be 1 because there's nothing in there. So our A is going to be 1. That means it's going to be a normal width, and it's going to open up. H is going to be 6 because it's the opposite sign of what you see. The equation comes with the negative sign. So what got stuck into x minus h, what got stuck in place of h, was a positive 6. And then k keeps the sign we see. So that means my vertex is going to be 6, 2. So to graph it, I'll graph it and then I'll write down steps on the first one. To graph it, we're going to graph the vertex first of 1, 2, 3, 4, 5, 6, 2. There we go. And we know it's going to open up. All I am super concerned with right now, because we'll get better as we go through the chapter. This is only our first section on graphing parabolas. If you just have it open up and draw it semi-right shape, I'll be happy. Remember that A being 1, that A works sort of like a slope. This kind of helps you get the shape going right, to know that if you go up 1 over 1, up 1 over 1, that those 2 points are going to be on it. And I'll talk more as we go along how I know where the rest of the points are and how I know that that one's not great. As long as you know that it opens up and you don't make it super skinny, super wide, you don't make it look like a horseshoe, you don't make it look like a test tube, you don't make it look like a V, you're in good shape. So all we did was step 1, graph the vertex. Step 2, use A to determine up or down, whether it opens up or down, and how wide or narrow. I don't want you to be super concerned with where all the exact points go. In this case, it wasn't wide or wasn't narrow. It was kind of normal width. Okay? Super easy stuff. If you have questions at this point, write them down. If they don't get answered when I graph the next few, then that's what you need to ask in class. Next equation. Let's do y equals negative. When I write the parentheses, I should really say the quantity x minus 4 squared. And we're just going to say that's it. So we're missing some pieces on this one. We gained some extra pieces on this one. So this time, what's A? This time A is negative 1. And from this point forward, once I give you the equation, you can try to graph these on your own and then use my graphing of them as your double check. A is negative 1, or at least try to pick up the A and H and K on your own, and then if you need to fix them up, fix them up. You have plenty of knowledge at this point because it's just like absolute value to graph these on your own, or at least pick out the A and H and K. So H going to be positive 4 because it got stuck in there. We had x minus h, and in place of the h, what got stuck in was a 4. I'm going to erase that. Okay, so h is 4, k, okay, nothing there. So what is it? K is 0. So our vertex is 4, 0. And because A is negative 1, it is a normal width. Again, not mathy term, just my way of talking about it. And it opens down. Okay, so all we have to do, step 1, graph the vertex, 1, 2, 3, 4, 4, 0, and I know with that A being -1, remember I told you my shortcut, I don't like graphing the ones that open down, so if I can get my iPad to lock, I'm going to flip it around, and it just makes it way easier for me to graph it when it's not going that way. So flipping your paper around, that's a good tip. Okay, so there it is. Now, on the other one, I forgot something, so we're going to do this on these. What's most important when I'm looking at these, I should see all this stuff written down, but I should also see the graph labeled because I want to know what you graphed at me. On these kind, all I really care you tell me about is the vertex was 4, 0. On this one, that happens also to be the x-intercept, so you can tell me that. We can't read the y-intercept on this one, so I don't need to write that. You don't have to put in the axis symmetry. You can put in the maximum of 0 when x equals 4. Okay, and so I got to go back and put that information on the last one as well. The last one, again, I should see all this information when I'm looking at the graph. I shouldn't have to go hunting for it. And the vertex was 6, 2. Once again, this one you can't tell me the x-intercepts. It doesn't have any, never will. And you're not going to be able to tell me the y-intercept because it's not on here. It's going to be way up high somewhere. Let's do y equals x squared minus 1. So this one got other stuff missing. This time a equals, h equals, k equals. There's no parentheses, but we still got to say, well, what's in front of x? In front of x, there's nothing, so it's an invisible 1. That tells us it's a normal width and that it opens up because it's positive. H, there's no parentheses. There's nothing that comes in between x and the squared. So that's how I know it's h that's 0 and k that's -1. You might want to make a note of that, right? Y is h 0, nothing between. You don't have to write this if you know you're super clear on it. Your notes don't have to look exactly like mine. You have to write more or less to suit your needs. And you can go back and fill things in later. But you might have had this question if I didn't answer it, and then you would have written down, why is h 0? I didn't get why you said that. And I would have said to you, because there's nothing between the x and the squared. There's no parentheses. Parentheses. That might not be spelled right. All right, so what's our vertex? Our vertex is 0, -1. So this vertex is just shifted down 1. So this time let's go ahead and draw the parabola first. Again, my A is 1, so I know I can go up 1 over 1 and just kind of do a rough sketch from there. All I really care about on parabolas is rough sketches. Don't waste your time plugging in a bunch of values. Vertex, 0, -1. This time, what's special about our vertex? It's also our y-intercept. And if you can tell, because you remember me saying, hey, if A is 1, you go up 1 over 1, if you can tell me the x-intercepts are 1 and -1, go for it. If you're not sure, don't tell me yet. Later we'll learn lots of specific ways to say that. But if you can clearly see where they are because you remember stuff from Algebra 1 or just like this one because it just happened to be up 1 over 1, write them in, but that's not a necessity on these. I will ask you to tell me it's got a minimum. The minimum is -1 when x equals 0. Remember, where am I getting that? The minimum is, that's a little dark. The minimum is coming from the y value of the vertex. The when part is coming from the x value of the vertex. Again, by this point, when I give you the equation, you should try to write these or graph these. At least write out the a and h and k before I do. Make sure that if you're having questions, you're stopping and writing questions along the way to ask your group when you come in. If your group doesn't know, then you'll ask me. So, lots of parts in this one. Stop and try to do the a and h and k on your own. Try to graph it on your own, and then come back and check with me. You have a pause button. A is going to be 1/4. That means it's going to be a shrink, or it's going to be wide. It's still going to open up because A is positive. H is 1, K is -3. So my vertex is 1, -3. I'm going to graph my vertex. 1, -3. It opens up, and that 1/4 makes me go up 1 and over 4. All I really care about is that you get it wide. And I'm not going to even try to guess what the x or y intercepts are. If my life depended on it, I could try to estimate, and I would probably say, no, I don't even like that side. Let's try that again. 1, 2, 3, 4, 1. I could probably come up with a pretty good guess at what they were, but all I care about is you get that it's really wide. Our vertex was 1, -3. You know, I'm guessing that the x-intercept is probably something like -8, -9, -10, something like that. And then positive, probably 8 or so. So it's probably -10, -8. We'll see. Maybe I'll check that in class with you. But again, I'm totally, estimating, so it could be more like 12. Who knows? All we really care about is this information. If you have this, you're golden. I will say it's a minimum of -3. That's the low point it reaches when x equals 1. Last one, try it on your own before I do it. Y equals -3x squared. Haven't seen one quite like this. Pause and try it on your own. So A is -3. That means it's going to be narrow, or really we want to call it a stretch. And it's going to open down because it's negative. H and K are both going to be 0. So pretty easy to graph. A vertex of 0, 0. It's going to be even narrower than the last narrow one I had. So I'm just putting those points. I still have my iPad locked. I'll actually turn this one around here. So all you want to do is make sure that you don't try to say that it's going to stay confined and go straight down. So try to at least, make it look a little diagonal. That's obviously all very wavy and ugly. Like I said, I'm not great at the upside down ones. But my vertex is 0, 0. What is that also? Well, it's got a 0 in the x position, so it's also my y-intercept. And it's got a 0 in the y position, so it's also my x-intercept. So that one point, when you have a vertex at 0, 0, it's the parent function because it's all things to all points, kind of, right? That vertex being at the origin makes it the vertex and the x-intercept and the y-intercept. It hasn't translated. It hasn't moved anywhere. All the rest of them move off that spot. This one has a min or a max? Has a max at 0 when x equals 0. So A and H and K do those same things they do for absolute values. It's just that we draw a different shape in between. And the A, it doesn't continue as the slope in the same way. Right? Slope is a same rise, same run, same rise, same run, same rise, same run. On a parabola, it will be a varying rise and run, and we'll learn more about that as we go on. And I want you to label whatever you feel comfortable labeling after the vertex. The vertex has to be labeled, and tell me the max and min. Beyond that, if you think you know the things, great. If you want to estimate the things, great. On vertex form, at this point in our life, I won't require more of you.